Hello, good afternoon. My name is Roberto Mora, and this tutorial is on how to find our standard quadratic function when the only approach we have is a tabulation table with certain data. So the problem says express the quadratic function that models the weight W a shelf can hold. So we want to model W. So the function is going to be called W, and the terms, it means the variable that it depends, it's the thickness, and we should express it as a D in this case. So let's put D. We want to find the missing. So the standard quadratic function is ax squared plus bx plus c, and we always want to find the values of a, b, and c. And usually we express the function in terms of x and y, the output. In this case, the only thing we have is different points on this table. This is a quadratic function, so it should be something like this. And these points we have right here on the table are different points around that parabola. So from those points, we want to get right here to this standard function that we can model any point we want, not only these ones on the table, but any. Taking the points we have, we can make a relation between inputs and outputs. But these are going to still be variables. A, B, and C are still variables that we don't know. So those are our incognitas. So we can take, for example, that first point and substitute it. So instead of y, I'm going to write 2 equal to a that we don't know. And then we're going to have x. And x in this case it's 1. So 1 squared plus b, instead of x, I write 1 plus c. We notice that we have now a function and we have 3 variables that we don't know. So if we want to find the value of 3 variables, we need at least 3 equations to actually solve the system and be able to know the values of a, b, and c. So how do we do other equations? Now we have one, so we need another one. How do we do it? We just take another point. So I substitute again, 8 as the output, equal, we simplify, and that one is going to be our second equation. So now we just need a third one. So I'm going to take the third point right here, 18 as an output, and as an input we have a 3 squared, and we get our third equation. So with these 3 equations, we should be able to solve the system for the variables a, b, and c that we don't know. So we need to take 2 first, and then we take another 2. We solve one variable. In this case, the easiest would be c, so I'm going to solve c. First, let's solve one variable from these 2 equations. So for me, c would be the easiest variable because the only thing I would do is multiply the whole equations times -1. So what I'm going to do is that I'm going to rewrite these 2 equations, but the first one I'm going to multiply it times -1 in order to simplify c. Taking these 2 equations, but the one it's now transformed, I'm just gonna add it, and you're going to see that at the end I actually simplify one of the variables, that in this case it's going to be c. So now I'm gonna take the other pair of equations, and in order to simplify a variable, I'm gonna do exactly the same thing. I'm gonna simplify c, Therefore, one of the equations should be multiplied times -1. I'm going to multiply the second one. You can do either, but I'm going to multiply the second one just because at the moment to add it, I want this number to be bigger and just subtract smaller and get positive from the beginning. But you can do it either way. So now that I have my two equations with the second one transformed, then I just add it, and in the residual you're going to see that I get simplified the c again. We're going to have a 0 right there. Now with these two new equations that I'm going to call 1.1 and 1.2, now are two equations with two variables, so we should be able, with one of the methods we know, to simplify one of the variables. In this case, I want to simplify b because I think it's the easiest. So what I'm going to do is multiply 1.1 times -1, and b is going to become negative now, so I should be able to simplify it. So from these two equations we inferred that 2a is equal to 4 when we add it, and a should be equal to 2 therefore. So now we finally have the value of a from our quadratic equation. So now we should use that a to find the value of b. So what I did right here is that instead of writing a, I'm substituting with a 2. Therefore, the only variable is going to be b, and if you clear the variable b, we may say that b is equal to 0, because we have a 6 right here, 3 times 2, so we're going to subtract 6 on both sides, and the answer is going to be b equal to 0. So at the end, I'm going to use equation number 1 because it's the easiest one, and I'm going to substitute a and b that I just found. So a is equal to 2 plus b that we know it's 0 plus c that it's now my only variable, that it's equal to 2. Therefore, c is equal to 0. So now that we know that a is equal to 2, b and c are equal to 0, then we can model our function w in terms of the thickness that we call d, and we just substitute. So we're going to have 2x squared, and the rest of the terms are going to be eliminated because b and c are 0. So this is going to be our final function that we can use to find these two terms right here. And we can also corroborate it. For example, if we substitute here 3, we should obtain 18, right? So 2, and then instead of x we write 3 squared, that should be equal to 18. So it's right. We can also find the input for that thickness. So for 4 centimeters, we can find the amount of weight it can hold. So I just have to substitute in the function, so 2, and then the input 4, we square it. 4 times 4, 16, times 2, 32. So the answer right here should be 32. We can also corroborate our answers with Desmos. All the points right now, I just wrote 2, but you can check all. So for the final question, if we try the inputs either 5, 6, or 7, we're going to see that the output is a number that is not 128. That is the one we want to find. So it's not the consecutive number, the one we're finding here. The answer is not 6. It's not. So if we go all the way to 8, we substitute it. So it's going to be 2 times 8 squared. 8 squared is 64 times 2 is 128. That is the actual output we are searching. So the answer right here is 128. For that thickness, for that input, x, we have a certain weight that it can hold for this case. In this case, 128 kilograms. That's the output. And that's it. I hope you enjoy.